All right. So what's going on in the college right now in terms of the
Sir,
chapters?
we're doing electrostatics.
You've started electrostatics.
Yes,
Okay.
sir.
And only one track.
Yes, sir. Only one track.
Okay. Okay. What you're doing in math?
Sir, in math, we just started circles.
Circles. Okay. Okay. So are you in the top batch?
Yes, sir.
Okay. So how is your scores like in the physics so far in the first year also?
First year was pretty bad, but I picked up in second year.
You picked up in second year. Okay. Mm, so how is the physics going then so far in the second year?
Sir, second year physics is going fine only. I just need to finish my first year backlog physics.
Yes, obviously. So the four chapters, vectors, kinematics, Newton's law, and the work energy theorem will
Yeah,
play a
those I
very
know.
major role.
Those I know, sir.
Those you know, right? Okay, good. I thought we can discuss some theory kind of thing. So we can do probably the work energy theorem in a little different
Uh,
way. We can start probably questioning, and then see if you don't know them, and then only it will be discussed. So
sir,
definitely.
sir, are we going to discuss a topic that I know, or something that I don't know?
We can also discuss the second year portion, that is the electric potential. I think you haven't started that yet.
Yes, sir. We like just started it today.
You started the electrostatics today, right?
Yeah, sir. I think,
Okay.
sir, can we do something like SHM because I don't know the chapter that much.
Yeah, we can also do the SHM chapter.
Yeah.
So, but SHM is somewhere in the middle, right?
Okay, so
So,
you want to start? Okay, sir. Then work energy is fine.
yeah, we can discuss SHM also.
Hmm.
But then it's okay. Let us do one thing.
Yeah.
Let's just understand where you are standing right now. A basic
Okay.
assessment would be necessary in the beginning because I don't know, right, where you are standing right now.
Yes,
So it
sir.
will be very hard for me to kind of catch up with where you are right now. So looks like
Okay.
you are confident actually.
Okay.
So it's okay. Let's see. I'll ask you some questions, okay? Not this and that topic. Let us see.
Yes,
We
sir.
will see how you will answer these questions.
Yes, sir.
That's all we will do in this class actually.
Yes, sir. Fine.
Okay, let's see. So first we will start with the vectors only. I will ask you a question for you. If you know, you tell
Yeah.
me no. Otherwise, we will do it. So
Yeah,
if I
sure.
give you a two-dimensional vector,
Okay,
so if I
sir.
give you two arrows, those are two vectors. You know
Hmm.
how to add those two vectors and get the resultant, right?
Yes, sir.
And you know how to find the length of the resultant and the angle of the resultant using
Yeah.
the perpendicular and then using the trigonometry and all.
Yeah. Yes,
I
sir.
give you a three-dimensional vector, so you can visualize the vector. For example, I plus 2j plus 3k. How to draw
Yes,
it
sir.
exactly on the three-dimensional axis.
Also, sir, are you sharing your screen because I don't see anything on your screen?
Yes, I am, but I'm not writing anything actually so far.
Oh,
This is
okay.
the blank screen. You can see
Okay,
this,
it's a
right?
blank screen. Okay.
Yes, yes, okay. So since it looks like it has to be a little, fast-paced, I'm just talking in a fast-paced. Anyway,
Yes, sir. Okay.
let's see. So a three-dimensional vector, if I give you,
Hmm.
you should be able to find out what is the direction cosines of that vector. Can you do that?
Yes, sir.
Okay. So for example, if a vector is given I plus 2j plus 3k,
Hmm.
how would you find the angle with the x-axis?
Angle with x-axis is it's basically the I cap plus 2j cap plus 3k cap, right?
Hmm.
So it's the coefficient of I cap, which is
Hmm.
1, divided by 1 square plus 2 square plus 3 square root
Yes. And how do we do that exactly?
equal to
Visually.
cos theta, obviously. Huh. Sir,
So you know how to make the right angle triangle, isn't it?
yes, sir. It's
Okay.
basically like we have to take component of the 3
Yes, and then we just have to, drop a perpendicular component and then
vector
we
on.
just use the trigonometry. That's it. Okay, good.
Yeah, that's it.
So you know the remaining things, right? Cross product, dot product, and all these things you know very well.
Yes, sir. Yes, sir.
Okay, good. Okay, let us do then directly the kinematics only. Let us
Okay.
directly do the two-dimensional kinematics then. Okay.
Okay.
So let's start with one question.
Hmm.
If there is a ring like this, and if a ball is thrown at the ring, pointing at the ring, so that it as if it is going to pass in a straight line. So
Okay.
simultaneously you cut the ring the moment you throw the ring through the ball. Okay, so the ring is cut exactly when the ball is thrown. The ball is initially pointing towards the hole, the ring. It's thrown
Yeah.
in that direction. So if you cut the ring like this, will the ball pass through the ring?
Sir, I have to know the distance between the ring and this ball and also the radius of the ring.
Mm, the radius of the ring is not necessary since the question is more about passing through a point. But yeah, if you want to know the distance, let us say the distance is d, and the height of this thing is h. So before doing anything, tell me what you're going to do first. Once
Oh,
again,
it's like it's in the 2D plane. Okay, I thought it was into the plane. Like,
no, this is in the 2D plane. This
yeah.
ball is pointed towards the ring initially,
Okay,
and
okay.
the ring is cut exactly when the ball is thrown. This is all happening under the gravity. There is a gravitation force downwards.
Yeah, okay.
Hmm.
And I
So
have to find out the velocity at which
no, you have to find out if the ball passes through the ring or not. Yes or no, that's it. The question is.
Hmm,
Or do you need to know some more information to do this
I
problem?
need to know the velocity of the ball, obviously.
Okay, take that as you.
Okay, and also the angle of projection.
Take that as theta. The angular position is given if the d and h are given.
Okay, okay, yeah. So, sir, I'll just take that as theta. Basically, we have to do u cos theta component,
Hmm.
and that has to um, match like it at some time t. At that
Hmm.
time t,
Hmm.
the height of the ball
Hmm.
like should
And
be
height of the
equal to
ring must
the
match.
falling of the ring.
Yeah, obviously. The
Yeah,
coordinates of the ring and the ball should match eventually when
yeah,
they're colliding,
yeah, yeah,
right?
yeah.
The basic collision condition, isn't it? Yes.
Yes, sir.
So then how are you doing this problem then? So you're going to write the condition. That's it. So you're going to write that the x coordinate matches and the y coordinate matches, assuming the collision happens after a time
Yeah.
t.
Yes, sir. That's it.
Then get the condition from there, right? Okay. But we don't have to do all that
We can
because
do equation of trajectory, can we?
you can also do the equation of trajectory. Even the equation of trajectory cannot be certain because the point through which the ball has to pass, we don't know which is that point actually. So the trajectory equation requires you to know exactly from which point it's passing through so that you can put that point and check if that point is satisfying the equation of trajectory or not, isn't it?
Yes, sir.
So, but we don't know that point also, right? So,
Uh-huh.
but this problem is very easy. We don't have to know U, we don't have to know D, we even have to don't know H. We don't have to know anything actually. Just you only have to know one thing. The ball, is it pointed towards the ring or not? But how is this problem so simple? Once again, think now. Now that you know, those are not necessary only.
Mm-hmm.
So
Uh,
whenever
so
there is a
is it like
relative
relative
motion,
velocity like of the y
yes,
component?
correct. So this is a relative motion. So you must now think clearly in the relative motion, right?
Hmm.
So once again, think
Uh,
now.
so, uh, sir, we don't even have to know the angle at which it's thrown also.
Nothing is given. Only it's pointed towards the ring, and the
Hmm.
ring is cut exactly when it's thrown. That is also given. Okay,
Okay.
two things are only given. Nothing else is given. So this is
Hmm.
like a child throwing the ball at the ring, thinking that it will pass through the ring. He'll point his gun in the ring, right?
Yes, sir.
So the father will come and he'll cut the string. So he knows
Yeah.
the physics. He knows the ball is going to pass through the ring actually. But
Yeah.
how? So this is the reason. Okay. So what we're
Hmm.
going to do is we're going to do the relative motion because there is a relative motion. And whenever you're doing relative motion problems, the first thing to find out is what actually any relative problem. The
Hmm.
very first thing that you have to find is relative acceleration.
Yeah, it's zero over here because it's in the same
Yes,
direction.
A relative is zero. Meaning, with respect to this, if you let us say you sit in the ring instead,
Yeah.
so you observe the ball. What is the acceleration of the ball with respect to the ring? Zero, because both are freely falling.
Zero.
Because
It'll
there
move
is
with constant velocity. Yeah.
yes, both are having only one force, that is gravitation force. So same acceleration, subtraction is zero. So that
Hmm.
means what? With respect to this observer, this is going in a non-accelerated way. That is, the velocity cannot change. That means the direction also cannot change. The magnitude also cannot change.
Yes,
So
sir.
that means it has to travel in a straight line.
Yes, sir.
So that means which straight line is it? That we have to find out now. If that straight line
Okay.
is passing through this or not passing through this.
Okay. Yeah.
Think about this. So ball is in straight line with respect to ring. Clear. But
I
which
have to
straight
prove
line
that,
is it?
right?
No, but which straight line is it? Exactly.
Okay.
Because is it this straight line? Is it that straight line? Or is it the same straight line? Or is it the other one? That will confirm whether it passes through or not. Okay. So you can do it like this, right? Now tell me something. The acceleration is 0. The velocity is not changing. That means the initial velocity and the final velocity are same.
Yeah.
That means the initial direction of motion and the final direction of motion are also same. So what is the initial direction of motion? It is not the velocity itself, because you're not observing from the ground. Because we are observing from here, we have to see the velocity from there only, right?
Yeah.
So the question is now, what is the velocity of the ball with respect to the ring and its direction? So clearly this is velocity of the ball minus velocity of the
Minus
ring.
V. Yeah.
So since we are doing initial, we can write the initial then. Initially, what is the velocity of the ring?
Initially, the ring is at 0. It's
And
gonna
velocity of the ball is this one, ub, same that is from the ground.
Yeah.
So that means it is initially traveling with this. The final velocity must also be that or not.
Yeah.
So that means it is same ub. So that means the velocity will never change the direction from the ub's direction. Therefore, it travels in the same line. And therefore, with respect to this, it is coming towards it. And it will never change the direction again, right? Because as this person sees, it should travel in a straight line. And that straight line is already traveling towards him in the beginning. It has to travel forever in the same direction. Therefore, it passes through the ring. Okay. Simple problem, right?
Yeah.
Okay. Let us do one more like this, since we are in one dimension here. Let's say I have two balls, both thrown up with different velocities with u1 and u2. The question here is to find the, again, they are both thrown on the same straight line, though they are represented beside each other. So the question is find max separation between the balls. So take a minute, think about this first, and then I will tell you something.
Sir, okay, wait, let me do it. So here also same condition will apply, right? A relative is 0.
Very good. The relative is 0.
Yeah, so they should be at, the separation will be increasing with constant,
With the
like,
time, the separation only increases. Correct.
yeah, so it'll only keep increasing.
Correct.
So I think when U2 becomes 0, if I'm assuming U2 is a greater
One
value.
of them collides.
Yeah.
Until then, it will keep increasing. Very good. Yeah. But actually, there is something to know here. That is okay. But then the problem is the time that you have to calculate. So you are assuming that the U2 falls first. So clearly, there are three cases then. U2 may fall first. I mean, U2 is more, let us say, clearly the arrow is more. But still, there are three cases in this. Can you see which three cases are those? So therefore, this problem is depending on the three cases based on which we can tell the maximum separation. If like everything goes good and the U2 falls first, then we can answer this first, right? So the max separation is nothing but the relative distance between them. So S12, which is the relative velocity into the time, A relative is anyway 0. So that is 0. So therefore, this is U12, which is U2 minus U1 into the time. The T is the T max if you want the S max. So the maximum time for which it will be in the air is until when the acceleration will be 0 relative. Otherwise, it won't be valid anymore, this one. So for this to be valid, the maximum time it takes is clearly 2u by t. That is the one case. 2u2 by t. 2u2 by g, I mean. So that the first ball is still in the air even after the second ball falling on the ground. Okay.
Okay.
So that means the ball is like this, falling down. U1 is falling down. And then the U2 has already fallen down. This is 1 and this is 2 sitting on the ground. So clearly after this, the separation decreases beyond this. Until then, it was increasing. After that,
Sir,
it
but
decreases.
what if
Hmm.
uh U2 is at its peak, like
That
at
is the
the
second
peak height?
case. So the 2 is fallen down and U2 at its peak. So still we say that the S max or the T max is still corresponding to 2U2 by G only, because anyway after this it falls down, right? So this
Hmm.
is the maximum separation possible. It cannot be more than that.
I mean, it's weird when you think about it because it's always gonna keep increasing. But then if we
Yeah, that's the next
like
question. That's
they
the next.
have to come back and meet each other again at
Hmm.
one point while one is falling and one is going
So
up.
that is, how is it explained then? How can you explain that? So because the equation says it's always increasing, but then it is also decreasing, right? So how is it
Yeah.
possible then exactly?
Um, I think it's something to do with vectors.
It is something to do with the validity of this statement.
Okay.
How long this statement is valid actually? As long as this is true. And why is this even true? It is because of G is
Yeah.
acceleration. That means both are in the air.
Hmm.
If they are both not in the air, this is not valid anymore.
Okay. So
So when one of them hits floor, A relative is equal to minus G or not?
yes, sir.
Not zero anymore. So therefore it decreases after that.
Yes, sir. I
This
got
have it
that. But
explained.
then,
Hmm.
when those two balls are projected upwards,
Hmm.
they will meet once at the starting point, and again when one ball is coming down and another one is going up, something like that.
Yeah, their positions overlap in two conditions. Yes.
Yeah, so maximum separation is also decreasing.
Yes, one of them falls, then it will decrease. Otherwise, it will keep increasing forever. For example, you remove the ground. Imagine. So there is no ground to fall. Imagine. It will increase forever. Isn't it? Isn't it
Sir,
obvious?
oh yeah, sir, I got that. But then when
Hmm.
they're projected from the ground, they have to meet once again, right? In the air, at least once.
Yeah, it depends. If it is this
On
case, then they do not meet clearly. If
yeah,
it is this
in
case,
this
they did meet. Even if it is this case, they meet, right? Twice they meet everywhere. Yeah,
yeah,
it's
they
true.
meet twice everywhere. So
Mhm.
at that second time, the separation is decreasing, right?
Okay, okay, yeah. So the thing is this. Let us think about this. Okay, if it is even true or not that they're meeting twice, right? So
Yeah.
you throw up, right? Let us say it's going up. So then it's coming down, isn't it? So the
Yes.
thing is, the separation is increasing. I think they don't meet again. Then that's it. They only meet once in the beginning.
Within how? Oh, wait.
This is just that we have to imagine this. That takes some more imagination. We cannot do it in a quick manner
Oh,
like this. But the equation is correct. The equation leads us to the conclusion that they do not meet again. Actually, they should not meet again, according to what you're saying. They should
yeah.
not meet again. Now it is up to us to imagine this and make it true. So if you imagine this, it's gone up, right?
Yeah, sir, I got it. I got it. Now I got it. Yeah, yeah. They don't meet, they only meet once.
Actually, this goes more higher, isn't it?
Yeah.
Because
It
for the
goes
more
more
time of flight,
higher.
it goes upper like this.
Yeah,
That's
that's
it.
what.
That's the only.
So they don't meet again. Yeah.
So the third case, in this case, the max separation is H2 max, not this one anymore. So that is not valid for this third case. Understood?
Hmm.
That's it. All right.
Here, Tmax is the time at which a two falls to the ground, right? Ball two falls to the
Yeah.
ground.
So both the cases, the answer is same.
Yeah.
So in both the cases, the S max is this only, but
Yeah.
it is not in this case. Here the S max is H2 max because it can still go up. It can still increase even after the other one falling down like that.
Oh, yeah. Okay. Yeah.
Okay. All right.
Hmm.
Let us see one more question. Mm, let us see a two-dimensional problem this time. Let us see the projectile motion. Let's say I have two projectiles. So we are again extending this concept and doing one more problem with this since we are already doing. Let's say there are two projectiles projected in two random ways, u1 and u2 with two angles theta 1 and theta 2. Same question again.
Yeah.
What is the maximum separation between the both? So this takes some time and patience to solve. So let us do this patiently.
Mm-hmm.
So clearly we must solve this problem using the concept of relative motion only.
Yes, sir. And we have to take X and Y components this time. And I
You
think we
can.
have to do some differentiation also.
Nothing like that.
Then?
There is no differentiation, nothing in this. If you want, we will do that problem also. But then this is a very straightforward problem, which applies the things which you learned here in a very straightforward way.
Oh.
So you can do it like this then. You can sit
Mm-hmm.
here and now, so reasoning is the most important thing in this problem, okay? Not just solving the equations. So we must really think what we are doing continuously. So like we did in the first problem, we will observe from one of the frames. So this one, let us say. So that means we will observe the motion of 2 from this one.
Yeah, okay. Hello.
So observing the motion means what? Observing the acceleration. So whenever you are doing relative observation, you have to find out A relative, U relative, and then based upon that, you have to think further down.
Hmm.
So what is A relative, by the way?
0.
So whenever A relative is 0, you know the conclusions, right?
Yeah, V
Relative.
relative is constant.
Yes, U relative is constant, or the U relative is equal to V relative. Even the velocities are equal.
Yeah.
Yes, so that means it is a straight line motion. So yeah, here is where I will leave you. From here, you should be able to get the answer. There is a bit of simplification in this,
Yeah,
a
okay.
bit of vectors used. So we'll see.
So according to this also, I think V relative should keep increasing. I mean the separation should keep increasing.
Maybe. So this is not one-dimensional motion anymore, but we can write S is ut plus half a square, isn't it?
Yeah.
So yeah, it should be S relative is equal to u relative into t plus half a square. Uh, yeah, with the increasing in the time, the S relative should increase, right? Obviously, correct.
Yes, sir. S relative is equal to V rel into time. So it obviously, and V rel is like constant. So obviously separation should always keep increasing.
Yes,
Oh, okay.
but you will not know the time in this case.
Yeah, we have to take cases again, right?
But there is a better way to do this problem.
Mm-hmm.
So that is by drawing the paths like the first one. So tell me something, okay? Let us
Hmm.
think the first problem's way. So you told it's a straight line motion. So who is straight line motion? Straight line motion. So with respect to 1, This is the one. Straight line motion, two moves in straight line motion. So now we are interested in which straight line is that?
The U2 bar minus U1 bar.
Yes, it is that one. So straight line is along U2 1 bar because it is never going to change. So let us do this visually once. The U21 bar is this U2 bar minus U1 bar. So that means
Yes, sir.
minus U1 bar
So
and
we have
U2 bar
to
have to
flip
add,
it that way. Yes, sir.
isn't it? Yeah. So that's what we get. And then we can add them. That's it. So the addition of these two ones will be this one.
Yeah.
So this is U21 bar, which is U2 bar minus U1 bar. Where this is minus U1 bar. Okay. So then we have to now find the angle between the vectors. So like, just tell me this angle actually, that's it, nothing else. So this angle I want to know now. The relative velocity, how much angle it is making with the x-axis. The separation between them has to be given and it is equal to d. So that means, yeah, let's see how to find this angle. This angle should be found very easily by finding this angle first. Alpha, let us say, is this angle. If we find alpha, we know this angle also.
Yes, sir. Theta 2 minus alpha.
Yes. So how much is alpha? Given theta 1, theta 2, u1, u2, and d.
Sir, cos of tan of U1 bar by U2 bar.
No, this is not
Okay,
right angle.
oh yeah.
So that's why I moved it a little bit. I'll move this a little bit more. So it's actually like this. Somewhat like this.
So we can use cosine rule.
You can do the vector additions. So tell me something quickly. If I give you a diagram like this, for example, so I want also you to tell me how exactly will you do this, because we know the formula very well, but we also want to be able to do this. If this angle is theta, and if I draw the resultant of these two vectors, which is this one, what is this angle exactly? Alpha.
Oh, that is sir, wait 1 minute. B
You
sin
drop the
theta.
perpendicular.
B sin theta by
Yes.
wait. A plus B cos alpha.
Yes, so this is u1 and this is u2 clearly.
Yeah.
So the tan alpha will be u1 sin theta
by U2 plus U1 cos
theta, right? So that means here you have to know the angle between vectors first in order to do this. You should not be able to do this.
Okay, yeah.
So what is the angle between vectors?
Angle between vectors. Sir, angle between U2 bar and U minus U1 bar, right?
Yes, angle between those.
It should be theta 2 plus theta 1.
Okay, so this is the angle. You can just put this one here.
Yeah.
And now you will see that it's theta 1 plus theta 2, correct?
Yeah.
So that is the same angle here, theta 1. So therefore, the angle between vectors is theta 1, and that's what we are using here actually in the formula. So therefore, tan alpha is that. So I'm going to write here tan alpha is equal to how much?
Alpha is U. Where? U. Was it U minus U1?
U1, you mean sine of angle between them?
Sine of theta 1 plus theta 2.
Plus U2 plus U1 cos phi.
Yeah.
So phi is angle between U2 bar comma minus U1 bar, and therefore phi is theta 1 plus theta 2 usually.
Yes, sir.
So therefore we got this done. So we got the alpha. That means we also know this angle now.
Yeah.
So this angle is clearly theta 2 minus alpha.
Yeah, theta 2 minus tan inverse that thing.
Okay. So now let us see the motion now. So it travels in a straight line, we said. and we also know it travels in this straight line. Okay, clearly the perpendicular distance is the shortest distance. So we are not doing here maximum separation. I'm sorry, we are doing the shortest distance. So that's why we didn't use that formula also. So that's what I was
Mhm.
wondering. The question is actually shortest distance, not the maximum separation.
Okay, okay.
Okay, now you can you think about this actually, how to do this?
Shortest distance. So, oh yeah, we have to find I think the intersection between that line and U1. No.
Mhm.
Uh, Sir, how it should, oh, we have to draw the perpendicular
Yes,
from
yes,
a point of projection to that line.
yes. You mean from this initial point to here, right?
Yeah,
Correct.
yeah.
Therefore, that's how we do this problem then. So this perpendicular distance is the shortest distance,
Oh.
clearly because that's the path of motion, right?
Yes, sir.
So path of 2 with respect to 1.
Hmm.
And this happens to be the perpendicular distance. This is the shortest distance. Therefore, perpendicular distance, which is the shortest distance, how much is it? You can tell me in terms of theta to alpha. You don't have to substitute this big thing.
Distance is d, right? So we can just do d2 cos theta 2 minus alpha.
You mean to say sine.
Oh, yeah, sine.
So d sine
Theta
theta 2
2.
minus alpha is the answer. Correct. That's it.
Yes, sir.
So that's the shortest distance between two projectiles. Okay.
Hmm.
All right. Okay. Looks like we have done some problem solving and you understood which kind of problems we solve in the classroom. So we only solve like 10 to 20 questions in a chapter and it will be covering most of the problems which you will see in the books. Okay.
Okay,
10,
okay.
20 powerful problems which will include a lot of things. So
Sure.
we will discuss something different now, just to give you an idea how the theory of physics also will be taught.
Hmm.
So we will do circular motion for that. So let us see how strong is your circular motion theory in the physics. So I'm
Yes.
sure you can solve the circular motion problems without a problem.
Circular motion or rigid body mechanics? Circular motion, right?
Only circular motion
Yeah, okay,
to
fine, sir.
start with. So I will ask you some questions. First of all, let us say there is a disk and you are observing from the disk frame.
Hmm.
This is the reference frame one. There is a block in the disk rotating with the disk with an angular velocity omega. And there is
Yeah.
also a block on the ground at rest. There is also
Okay.
another observer on the ground who is at rest.
Okay. Everything horizontal plane, right? Yeah.
This is all in horizontal plane, no gravitation force.
Yeah.
So we see that this block is going with the disk, so it is rotating with the disk.
Yes,
Anyway,
sir.
so what is the acceleration if something is rotating in a circular motion? So if an object is there, right, it's going
Yes,
with a
sir.
velocity v and it's rotating in a circular. What is the acceleration? Is it accelerating first of all?
Sir, is it moving with constant speed?
Yes. So
Okay,
here
then
the
it's
question is this is
v square c.
constant speed. Okay. So the
Okay.
first question is it this I'm talking about this one? Is it accelerating or not? First question.
Yes, sir. It has to be accelerating because the direction is changing.
The direction of velocity change, right? That means this acceleration is because of the change in the direction, clearly.
Yes, sir.
How do we find the acceleration? And by the way, how much is the acceleration? We know
V
that
square by r.
v square by r, right? Can we do this actually? Do you know how to find the acceleration in the circular motion? Let us
Uh,
think about that for a moment before jumping into this one.
uh, yes, sir. 1 minute.
Mhm.
Yes, sir. So basically, we can take a very small element of that circle, d theta element.
Mhm.
So when
Yes,
we take
yeah.
that d theta element, we know that velocity is equal to distance by time.
Mhm.
So yeah, ds is equal to r d theta. Now we divide by dt on both sides because it's a very small interval, and we can assume that velocity is about the same direction. And
Yes, so you are deriving the other one actually. Anyway,
Yeah.
this is speed, which is equal to r into omega. Correct. So you have derived the equation v is equal to r omega. Very good. And then
And then after that, acceleration is, oh yeah,
mm,
we have to take one v1 from one point of that uh,
it's always v only,
radius to
right?
another thing.
It's always v only because it's constant speed.
Yeah, sir. And now we have to do
You
change in
can
velocity. Change in velocity.
yes, you can do the change in the velocity. Yeah, the diagram, right? Like
Yeah.
the v1 minus v2, but that is very hard, and that way you'll not get the answer also. That is only
Oh.
to understand the acceleration, what is stands for. It's like the subtraction of the velocity vectors, isn't it? Yes, but that will not give you. But why can't you differentiate this one directly? Let's say it's not constant speed.
Oh. Yeah.
So if you differentiate, what will you get?
A is equal to I don't need to use product rule because R is
R
constant.
alpha.
R alpha.
Correct. So, but we didn't get this one, right? Actually,
Yeah.
we got this one because this is a speed relation in a circular motion. This
Yeah.
is not the velocity relation because velocity will have direction and this has no
Yes, sir.
direction. So you got actually tangential acceleration, isn't it?
Yeah. Yeah.
So we derive tangential acceleration. Anyway, so this is how we do it. First of all, we need to write the vector, the velocity in circular motion. Using the same equation, we can do that. So can you convert the same equation in the vector form using the cross product?
Yeah.
You can.
V bar is equal to omega cross R.
Yes, that's it. So this will include both the speed and direction. So
Yes,
that means
sir.
this must give you both the accelerations. So the total acceleration, A total, is nothing but the differentiation of the velocity term itself. So this
Oh.
is omega bar. Differentiation of r bar is v bar.
Hmm.
And differentiation of omega bar is alpha bar plus r bar.
Hmm.
So therefore, we got the total acceleration. We see that omega
Oh,
cross r.
okay. That term is the centripetal acceleration.
Yes. So all omega is out of the screen. Velocity is right side. So if you cross them, it will come radially inwards. So this is
Inwards.
minus r cap direction. And this alpha cross r. Alpha, let us say, is same direction as omega. Alpha
Hmm.
cross r will be tangential. So plus or minus v cap will come along the velocity or opposite to the velocity vector, isn't it?
Yeah.
So
And alpha
therefore,
is
you see
also
that
zero in this case.
it is zero in this case because it's uniform circular motion.
Yes, sir.
Right. So therefore, omega cross v is the central acceleration, A central and A tangential. Therefore, whenever the velocity is rotating, it can have the acceleration due to the rotation or due to the change in speed. And those are the
Yes.
ones. So that means we need to put a force to rotate it. And that force will provide the necessary central acceleration
Hmm.
or to change the speed, necessary tangential acceleration. Okay. And here we have the scenario. So the question is this. First of all, let us attach a spring here so that it's not friction force and it's a visible force. Because spring force, we can read it clearly.
Hmm.
Now, the spring is expanded clearly, otherwise it
Yeah.
won't rotate in the circular motion. So
Yeah.
with respect to the object, with respect to the observer 2, what are the forces on the object at rest? It should be very simply the
With
normal and the
respect
gravitational
to
force.
with respect to observer 1 and 2.
No, with respect to 2, it is this one, right? Let's say
2
this
is
is
the
capital M.
observer on that ground. That's
Yes.
small. Okay.
And let us say this is small m. So that much is very easy. And what is the forces on this one? With respect to him, you tell me now.
Yeah.
Normal force is there, gravitation is there. Ignore them.
Yeah.
Other than that, what are the forces? This is in circular motion, right? With respect to
Yeah.
the 2,
So since he's in inertial frame, there's no need of a pseudo force. So it'll just be kx is equal to mv square by r. We have to
only
equate
forces we should write. So what are the forces then? Only forces.
the only force acting towards the centripetal acceleration, like contributing to it, is the spring force. That's it.
There is no centripetal force.
So we equate centripetal. It is not centripetal acceleration. Something.
Yes, centripetal acceleration, but there is no centripetal force in circular motion.
Okay, in circular motion, there's no centripetal force. Okay.
Is there or not? I'm asking you.
Sir, there should be. Otherwise, how will the object move? Like, how is there
So that
acceleration
means
without force?
should I put another force?
So I didn't get you. What?
So shall I put one more force here, or only kx is the only force?
Kx is the only force, right?
Okay, so I should not put one more force.
No, because we don't. Sir, I think you're talking about the v square by r, mv square by r force. That's only put if it's a non-inertial frame, like in one.
Okay, good. So there is no force called mv square by r. Actually, there is an acceleration it has. That acceleration we will write, right? V square by r. Correct. Yeah. So
Yeah,
that's why you say kx is equal to mv square by r.
yeah.
Okay. All right. Good. Let us write the forces on the rest object with respect to one. What should they be? So with respect to one, there are two things we want to do here. We want to write the F net, and also we want to write A observed, the observed acceleration. Okay. So what is the
Mm.
acceleration observed with respect to 2? Now we are doing the problem with respect to 2, I mean with respect to 1 on capital M.
Mm.
So what are the forces you tell me, and then what is the observed acceleration also you should tell me. Okay, let's see.
Sir,
With respect to 1,
observed acceleration A relative will be zero because according to him, he's just looking straight and the ball, I mean the block
he
is
is rotating.
in front
He's
of him.
rotating. His eyes are moving consistently.
Yeah, sir, but the block is always in front of him, right?
This block not. We are writing on this block, capital M.
Oh, that block. Okay, okay.
Yes.
Okay. Sir, okay, he's rotating. So there will be an mv square by r pseudo force acting on it. Pseudo force acting on the
In which way?
capital M block. It'll be directed away from the acceleration of the one guy.
So is it right or left?
It should be right.
How much?
M omega square r. Wait, but r is the distance between him and.
Yeah, that's okay, no problem. We'll learn. We're not writing that much strictly, so let's take it as R only. Okay.
Yeah.
What is the A observed?
A observed will. Oh, there will be. Oh, wait. A observed. A observed, we have to use vector form, I think now. Wait,
But then this is observation only, right? So if he observes, how much is the omega, by the way, of the capital M? Same.
how much is the
Omega
omega
is
of the capital M?
hmm, omega of the capital M. This is the capital M. I hope you are
Hmm.
able to see this. So it is same
Okay.
as omega, isn't it?
Yeah, it'll be the same as omega, right?
So then if the angular velocity is omega, what is the central acceleration is omega cross v, which is omega v, or which is omega into v simply.
Hmm.
V is omega by r. So omega's, I mean omega r. So omega square r you will get, no?
Yes, sir.
So that means this must be omega square r. That's why you written this omega square r, right? The acceleration is
Yes.
omega square r, isn't it?
Yeah.
But this is not correct. This is wrong. What is wrong in this? Can you identify quickly?
So there'll be. Will there be tangential acceleration? I don't know. There won't be
There's
tangential.
no tangential acceleration we have to worry about because alpha is zero.
Sir, so will there? There won't be.
There won't be because alpha is not there.
Yeah.
When there is alpha, then only the speed will also change, not otherwise. When alpha is zero, it will be constant omega and therefore constant like uniform circular motion.
Hmm.
So
Sir,
let's
I'm not
try.
sure.
The acceleration is omega square r, definitely. Why not? But
Hmm.
what is the direction of the acceleration? I want to ask you. Because acceleration will have a direction also, no? It's a vector
Yeah.
quantity. What is the
Yes.
direction of acceleration in this case?
Sir, sir, the thing is, this person is moving in a circle, right? So his
Yes.
acceleration will always be pointed in ground reference frame will
So
always be pointed towards the
with respect to him, we are asking. So with respect to one, we are doing this problem.
center. So
Hmm.
yeah, so it'll be opposite of that. So radially outward.
Radially outward, right?
Hmm.
So why is it radially outward? You must say that its omega is like this, isn't it? At least.
Yeah,
So that means the acceleration direction is radially outwards. How is it radially outwards? Exactly.
because pseudo force is mass of the object into acceleration,
Okay.
opposite acceleration.
Okay. So let's see this. First of all, the acceleration is how, right? Direction. So clearly we know this already, whether it's going clockwise or anti-clockwise, the acceleration is towards the center, isn't it?
Hmm.
Without a doubt.
Yes, sir.
That means its acceleration is towards the center,
Yeah. Speed. Yeah.
isn't it? If
Yes,
something
sir.
is going like this or like that, why does it matter? The acceleration is towards the center, right? A central.
Yeah. Yes, sir. Yes, sir.
In fact, it is omega cross v. Let's do that omega cross v then. V is like this. Omega is into the screen. If you do omega cross v into the screen cross v, it will come this way. Check
Yeah.
that.
Yeah.
Anyway, so that means there is acceleration, but there is no force, which is violating Newton law. Obviously, we know that it has to violate because this is a non-inertial frame. And the pseudo force we then we put to explain what we observe. Therefore, what is the pseudo force then? In which direction is it?
Radially outward.
If the pseudo force is radially outwards, then is the Newton's law correct? Is it corrected
Yeah.
Newton law?
Yeah, it will be correct.
No.
But what?
If the acceleration is left side, which direction the force should be according to the Newton's law? It should be left side, right?
Yeah.
So then he must think there is a force right side or left side.
It's right side.
No, you are sticking on to your answer actually. You're not thinking. You
Um.
know that the answer is right side, so you are sticking on to that only. But I want you to think once. Okay, that's why we are doing this. Okay.
Yeah, sir. I got it.
Yeah.
Okay. So
So which direction the force should be then? If the acceleration is left side.
it
Think
will
about
be
this.
it should be the opposite side because
Why? See, okay, tell me what is the Newton's first law in the law of inertia? Means what? The body stays in its state of motion
yeah,
unless
unless acted
acted
upon
upon by a
by
force, which is the second law.
yeah.
That means if you have to put a force, right?
Yeah.
Otherwise, it's not going to change the state of motion. That
Hmm.
it is accelerating right side because there is a force in which direction? Right side.
In the right side. Okay.
But will it accelerate right side and the force will be left side? Is it possible like that? If there is only one force.
No, that's not possible.
So here, that's what you are answering then, isn't
Okay.
it?
Hmm.
The acceleration is in which direction? Towards the center. So
Yeah.
therefore, what is the force? Net force should be in the direction of towards the center only, right?
Towards the center. Yeah.
But that is not a real force. So therefore, this pseudo force. So this pseudo force, as you can see, is not the conventional one. It is opposite to what we write usually. So this is F pseudo
Hmm.
is equal to omega square r into m towards the center. Understood?
Yes,
So
sir.
that the acceleration observed is also towards the center. This is called as Coriolis force.
Mm-hmm.
Okay, this is not called as centrifugal force. The centrifugal force is the force which you're talking about here. Let us see this one now. So with respect to one, we will write on small m. Okay. So as the small observer is observing, what is the A observed? Let us see. So as he sees it, right? The block is always in front of his eyes, isn't it?
Yes, sir.
It's not going anywhere. It's not like this one. This is not going anywhere. It's always in front of him. So what is the acceleration observed clearly?
It will be 0.
Zero, right? Without
Yeah.
a doubt.
Yes, sir.
Or is it in circular motion and we have to think about it? It is zero, isn't it? It's in front
Yeah,
of
it is 0.
Now, what is the forces acting? So one more thing to know here, all the real forces exist from every single reference frame and they will be the same value. That means what were the forces from the ground? They also exist from this reference frame. No questions asked. So I have to put a kx immediately.
Yeah. Yeah.
Also normal and gravity, which I'm not ready. But other than the real forces, is there any other force? Nothing else.
Nothing
So, but
else.
then this is not explaining, right? That's why we put a pseudo force. So which direction do we put a pseudo force in this case, clearly? If it has to not
Either
accelerate.
direct. Okay, that's the point. Okay.
Okay, this is why we put this, isn't it?
Got it.
Okay, so
Okay. Yes, sir.
this is not a big difference. I mean, you would have already solved the problems even without knowing this, but
Yeah,
it
yeah.
makes a big difference when you are doing especially some more difficult problems. Okay,
Yeah.
the clarity matters. The pseudo force in this case is equal to kx. But then how much was kx? Let us
Oh.
let us see, right? Because from the ground frame, if you find it, can I use it here also? I should be able to because the pseudo force, I mean, the real forces don't change with the reference frame. Even the value will be the same. So let us go back to the ground frame and find kx. So if I write Newton law, I got the kx is mv square by r. So therefore, this pseudo force is also mv square by r.
Mm-hmm.
Okay, a simple explanation of the pseudo force in the circular motion.
Mm-hmm.
Okay, so this should also clear you how the
Yeah.
theory is approached in the class. Anyway, looks like you are very good in physics, and as your father was telling, you need a push definitely, so that you
Mm.
can really excel in the subject. You know, because a lot of times physics is only treated as maths, unfortunately,
Yeah.
ignoring the physics part. Okay, which matters.
Yes, sir.
Um, anyway, let us do one last problem. Anyway, we have done this, right? So let us see. So here is the problem. There is a disk, and this disk has a hole, a groove.
Okay.
So we are placing a ball at the center of this hole. So the ball can fit in the groove comfortably, no friction,
Mm.
nothing. The ball's mass is m. Initially, there is no velocity for the ball. The disk is already rotating with an angular velocity omega.
Sir, vertical or circular?
This is a horizontal plane.
Okay, horizontal plane, fine. Yeah.
So the question is this: if the disk is left at, if the ball is left at the center like this, and the
Hmm.
disk is already rotating, the radius of the disk is r. Then the ball, what happens to the ball? Nothing should happen because you left it at the
Nothing should
perfect
happen
center.
because R is 0.
Yes, but if you lift it a little bit off, then it will fall out.
Yeah, it will fall out.
So with what velocity will it fall out? You have to find the velocity which
Sir,
is
if
the
there's
ground.
no friction in the groove, then it'll just go with mv square by r. No, no, no.
Uh-huh.
Oh, wait, wait. Yeah, I think it should just go with mv square by r.
But then what is V again? And the question is to find velocity of ball, not the velocity, obviously, the speed of the ball
Hmm.
when falling out. Let's see. So take a minute and try this one.
Okay. Oh, we have to. Sir, the R is changing, so we have
The
to integrate in.
Yes, there is an integration in this, isn't it?
Yeah,
Yes.
yeah. Sir, wait, almost done. Oh, wait, what? I just got omega into R.
Omega into R you got.
Yeah.
Okay, maybe correct. Let's see. So let us say the ball is here at a distance r
Hmm.
from the center. What is the force on the ball?
Uh, it will have a m omega square R force.
So the force on the ball is so we are solving the problem from the central rotating
Yeah.
frame. So
Yeah.
the force is m omega square r. All right. So this force is changing. So then what do we do now?
Yeah. So also I have a doubt. In this, we're taking the force from the center of the circle, right? So will that be a pseudo force or will there won't be a pseudo force, right? There'll be a real force, m omega square R here.
Okay, so if you're standing in the center, there is no force in this direction, first of all. As you can
Yeah.
see, there is no real force. The only forces acting are normal forces, which are acting this way actually.
Yeah. So they'll
So
cancel.
this is a pseudo force only, definitely.
It'll be a pseudo force only, but then so the middle of the circle is accelerating.
No, it is not. It is rotating. You're observing from a rotating frame. So you have to put a pseudo force according to this rule which we made here. So
Yeah.
whenever the conclusion from here is that whenever you are rotating, you must put a pseudo force and in this direction, and like same thing. So here, since we are solving the problem from the rotating frame, we had to put this force. Otherwise, we could not use a Newton's law. Okay, that's the reason why we put this force, right?
Yeah.
That much is the explanation. That's it.
Okay.
So now what do we do? So we know that the acceleration of the ball is how much? Omega square.
Yeah, omega square r. Now we can write that as v dv by dx.
Yes, so v dv by dx or omega square into
dr.
x dr. I mean, let's write x only.
Yeah.
So therefore, we got the answer, right? So v square by 2 from the limit is equal to omega square x square by 2 from the limits.
Yeah.
What are the limits? The limits is x is 0 from r.
0 to r, and this is 0 to v. V is what we have to find out.
So therefore, v naught is equal to
Omega r.
Omega r. That's it. But is that the speed with which it is coming out? The question is to find speed of the ball when it is falling out.
Oh, so we have to add that omega r component also.
Therefore, v of the ball falling out is equal to how much?
Omega
Root
square to root 2 omega square. Yeah.
Okay, that's it. Yeah. All right.
Yes, sir.
Okay, all right, Pranav. So I hope you have understood my class very well.
Yes, sir.
All right. So anything else you want to ask? So you are asking about the SHM, right? We can discuss the SHM. But if you are, unless you are not in a hurry, unless you are in a hurry, we can discuss SHM. Otherwise, we can see some more problem solving from the all the chapters and eventually come to SHM. However you say.
Okay,
But
sir.
this was the demo class, so I had to kind of do some problem solving only to check. So I think I have a fair understanding of you now, where you stand. So yeah, we can also discuss system if you are in a hurry like that. Otherwise, we can do from the problems. It's better to do from the beginning because the system again demands you to know very good amount of physics, because the problems which we'll do in SHM is not only SHM, it's the whole mechanics in general, right?
Yes,
so
sir.
even many cases will come. So if you just wanted to discuss SHM theory, then that we can do. Why not? But I think that is no problem.
Sir, so are we going to like if
Problems we will
yeah,
do.
sir. So we're gonna learn physics from the start, like from
We'll do
mechanics.
problems. Yes.
Yeah,
We will not like
problems
do
only.
problems only we will do, because looks like you already know the theory properly and no doubt about that. But somewhere where you have to know a little bit more depth, that parts only we will do the theory. But the remaining only will do problems, because those problems will be a little different problems only. Okay.
Yeah, like these types of problems are good. They're like conceptually good.
Yes. So
Yeah.
this is the kind of problems you must be doing, and only then you will really understand the concepts to apply. Because doing easy problems, even 100 and 200, right? It won't help you actually. So we will only do few good ones, so that you really become proper in the problem solving. Okay.
Yes, sir. So we'll start from
Yeah, we can start from the vectors.
kinematics till
Kinematics, actually, yeah. And then we will do some problems in the 1D relative. There are some problems to be done in the relative, which are very important. And then we will do the two-dimensional, and then we will do the Newton's law problems also, a few here and there. And then we'll also do some here and there circular motion problems, and then also friction problems, more importantly.
Yeah, friction also I have a bit of.
Yeah, and then also work energy theorem we will do. So we will skip the friction, and we will also skip, I think, a few parts here and there we will skip mostly. But we want to catch up with the second year portions actually eventually, right?
Yeah. So how long will that take?
Yeah, we will do it very quickly. So we won't solve much
No,
problems.
sir, I don't like it's not like I want it to be done very quickly. I want to be
But you should tell me that, because if you want to catch up with the college, and if you want to discuss the second year portion alongside, we can do that, right? But if you are not concerned that much about your
So the
second
thing
year,
is, we're doing electrostatics right now, so it's not related to mechanics that much. It's completely different. So in this time, and electrostatics is like a very big chapter. Like
yeah,
so it's I think in that time if I catch up on mechanics, then that would be good.
yeah, and also the electricity will be. I mean, the electrostatics. There are a lot of things to discuss. So maybe you will learn. So is it good, the teaching and all everything? I think it's good, right? You are able to
Yes,
learn
sir.
properly.
Yeah, that I can learn. Yeah.
So then why didn't you catch up the first year?
Sir, so basically I had a bit of problem in math initially.
Okay.
So focused more on math, and that time I was actually good at physics, but I had to leave physics for a bit, and I spent so much time on math that by the time
Okay.
we were done, I was done doing my math.
Yeah,
We
good,
had
good.
RBD 1, 2, heat, everything was done, and then I didn't know anything.
Oh, okay, okay. No problem. So if it is like that, then you will also face some problem in the second year, okay? So especially even in the electrostatics, there will be some problems related to the mechanics, even in
Yes,
the
and I can
magnetism.
do very basic, I can do like most
Okay,
basic
okay.
problems. Not,
Yes, yes, you
I'm
can
not
do that.
completely blank.
Oh, yeah, yeah. No, no problem. So I think I understood the situation. So tell me then, which chapters you left like that?
Sir, can you not tell my dad?
Okay, okay. What did you say?
Can you not tell my dad? I'll tell you.
No, yeah, I'll not tell him definitely. You
So,
can tell me.
so RBD 1, RBD 2,
Hmm.
it started from collisions actually. It was before that.
So
Mm,
you left a bit of collisions also.
yeah, a bit of collisions. Then
Okay, I
RBD 1,
understood. Okay, no problem.
like
So that
from there
means
on.
all the way up to fluid dynamics. I mean, not the
Fluid
fluid
dynamics
dynamics.
and everything in heat.
Everything you left. This is the whole first year portion you left, right?
No, in
I
heat, in
understand.
heat, in heat.
Yeah, heat and thermodynamics also.
Yeah, that's it.
Okay, no problem. These are very, very important topics, and you must be very good in them.
Yeah,
And the mechanics is a little bit on the harder side, and we cannot do a system if you don't know the rigid body dynamics.
yeah,
So also fluid dynamics, you have to be an expert. Then only it
yeah,
is
yeah,
worth it. Then only it is worth doing. There's nothing in a system actually.
yeah.
SHM is not even a chapter. It is just some problems. That's it, right?
Okay, yeah,
Written
yeah.
in a certain
Everything
way,
is the same type of problems. That's what I also observed.
Yeah, like there is nothing much to do in SHM as such. It
Yeah.
is only like a practice of the mechanics.
Mm-hmm. Okay.
Okay, no problem. I understood. So then we will do this. We will do some problems. I think if you're concerned, again, one more thing to ask is if you want to catch up with the secondary portion or not. That's a question to ask. And it is that will decide how much depth we will do these topics also. Because if you want to catch up with the secondary portion, we can actually do that.
Hmm.
We can also catch up with the first year portion later on. Okay.
Hmm. So
Or we can
if I told you that I didn't want to catch up with first year, I mean,
second year
second
portion.
year portion, then how long would it take me?
I mean, it's nothing like how long. So it depends, right? Like I think you're very good in catching up very quickly.
Yeah,
So
yeah,
it
yeah.
shouldn't take much time, but usually we don't do many classes. So it's like only 3 hours a week is what I do classes usually, right?
Okay. Oh.
So that will take time, okay? But then the topics as such and quick, it is very fast, as you can see. We
Hmm.
finish very fastly. We do the theory also very quickly. Everything is very fast, but then it is stretched across the time, right? That will take time. But you don't have to worry about that. If you have holidays and all here and there, right? We can also finish in the gaps. So I think this is what practically works for you.
Hmm.
This is what you will see working in the future. We will start the first year portion, right?
Hmm.
We will start the problem solving
Okay.
from the kinematics itself, so that you are very good from the beginning only. And you will see that you will have problems catching up with the second year. So
Hmm.
in that case we can do the second year as well. So it's like you can do one session of
Hmm.
mechanics, right? Two
Hmm.
sessions of electrodynamics in that case,
Okay. So
or
if
the
I
other way.
have a problem catching up, then we'll do.
Then we will do the electrostatics as well, okay?
Okay. Okay,
Okay,
fine.
otherwise we will only do the mechanics. So if you are
Okay, okay.
able to do the problems and all, that should not be a issue.
Yeah, that
You
makes
can
sense.
also come up with the doubts in the second year.
Hmm.
But it's better to clear the doubts in the college only, you know,
Yeah, yeah, yeah.
because it will take up the time in the class again.
Yes, sir.
Okay.
That's true.
So that should be the plan. I think you will get the clarity only as we go. You won't get the
Yeah.
clarity in the beginning like this. Okay. But what I observed mostly is that people
Yeah.
do want to really finish the first year portion, you
Hmm.
know. So because that will be really worthwhile for them, because then they will really be good in the second year physics also. Only then you
Mm-hmm.
can do any problem. You will be worryless, right? Obviously.
Yes, sir.
Yes. So that's the situation we want to get into actually. Not the situation where we are managing, here and there. That's not good for you in a long term view, right?
Yes, sir. Got it.
Yes, yes, that's it. So, all right.
Yes, sir.
Pranay. Yes, I remember your name. Yeah. Okay, Pranay. So I'll see you then. We'll talk.
Yes, sir.
All right.
Thank you.
Bye.
Bye, sir.